Hey, welcome back. This is Mr. Kelly at Kaiserslautern, and today we're going to be learning about sampling methods. Now, that's something that you've probably been a part of, these sampling methods. It's when people go out and they collect a sample. And normally what they do is a survey or they take a poll, and the idea is that they want to learn about a bigger population. They want to learn about what you think about something, and hopefully your opinions reflect what the general population, their opinions. And so normally we do this because the population is too large to go out and ask every single person. So, normally we just take a sample. And sometimes the sample's 10 people or 50 people. And sometimes it's as many as 1,000 or thousands of people, depending on, who's doing the sampling and what they want to accomplish. Now, for us, we got to learn some terminology here. And by the way, this is a topic that goes deep into AP stats. So if this is easy for you, then maybe you should consider taking stats next year. All right, so we're going to talk about these words we need to learn. First, the population. You've heard that before. The population in the United States, it's every single person. It's the entire group of individuals that we want to learn about when we sample. That's what the population is. So maybe you want to learn about, you want to know what the parents at your school think. So the population would just be parents of students at the school. The sample, that's the small part of the population that we study to learn something. So if you ask 50 parents, then those specific 50 parents would be your sample. Now, how we go out and collect that sample is called the sample design. Okay, there's lots of different ways we can do that. Ideally, a good design is going to represent the population well, which means that when I take my sample, my results are just like the entire population. I learned basically exactly what I was supposed to right on. Now, sometimes if you have a bad design, then the results you get don't match reality. Okay, sometimes there's some bias involved, and you've heard the word bias before, but bias is when you systematically favor some outcome when you take a sample. So let me give you an example of this. Suppose you wanted to know about the lunch at school. Okay, well, in our school, some students can go off campus. Well, maybe you go out to take a sample. So you go out at lunch and you go out in the cafeteria and you sample students and you say, hey, what do you think about the school food? And they give you all these results. Okay, now I would argue that that is biased because of the students who go off campus. There's a reason they go off campus, right? Some of that reason might be that the food, they don't appreciate it at school. So when you go to the cafeteria and you select people there, you are leaving out other people, and so your sample would be biased. It would say probably that more people like the food at school than actually do. Maybe, maybe not, but potentially there's some bias there. Okay, so as we said, bias is systematic. It's when you systematically favor an outcome. Okay, so suppose we want to gather information on whether students at your school prefer block schedule. Okay, with 85 minutes, or traditional schedule with 45-minute periods. A bias sample, another example, would be to ask 50 of your friends on social media. Okay, if you just put up a poll, you put it on your snap face, and you ask people, hey, 50 people, tell me what you think about, block schedule or traditional. What's likely to happen is your friends, they probably have the same views that you have. Okay, maybe you're all seniors, maybe you're all juniors, or maybe you're all girls, or whatever the reason is. But they're going to be similar to you because guess what? That's why you're friends, right? I mean, you have things in common. So asking them doesn't necessarily represent the entire population. If I wanted to do an unbiased sample, then what I would do is probably number everybody in the school, and then I would select them randomly. I'd go up and say, you have been selected. I need to know what your opinion is. And that would be an unbiased sample, I would hope. Okay, so how are we going to do that sampling? Well, we're going to use our calculator. Your calculator will select people randomly. And when I say people, there's a step to it. You have to assign people numbers. But you have a function in your calculator. And here's how you get to it. You hit the math button, you go to the right 3 times, and you choose 5, and I'll show you what that looks like in a second. But you're going to get this function that says random int. That stands for random integer. So in your calculator, this is going to be the smallest number that you want to sample from. Usually it's 1. Okay? And then this is going to be the largest. So if you're pulling from 200 people, then you'll use 200. This last number right here is how many people you want to pull out. So it's how many numbers you want. Whoa, that was weird. So this last number is how many numbers you actually pull out. So let's see what that looks like with our calculator. We'll pull that up. Here's Mr. Calculator. So what I want to do is I want to pick the math button right here. And you go over to where it says probability. And then you'll notice that one of the functions is choice 5, which is random integers. Don't choose choice 1. We'll learn about that in a few minutes. But, you know, sometimes you get this, you know, intermediate screen right here. Sometimes you don't. But if I want to select 200 people, I would say, all right, the first thing I'd do is I'd number all the students from 1 to 200. The lower bound I'd put is 1. The upper bound is 200. And this n is how many people you want to select. So if you want to choose 10 people, you can make that 10 and they'd all come out all at one time. But I just like to use it as 1 because when I hit enter, then it selects one person. So this represents that person number 5 has been selected. Okay, this is person number 37. And you can keep hitting enter and it just keeps shooting out the random numbers. Now, every calculator... Whoa, that was weird. I got the same person twice. What are the chances of that? I just can't believe that happened. The chances of that are 1 out of 200 times 1 out of 200. Well, that it was the number 160. But my point is this. You'll rarely get the same person. And we got the same person twice. So when that happens, we just ignore it. Let me go to the next person. Okay? So that's how we select people using our calculator. Now, before we start actually pulling out random numbers and answering questions, I want to more or less ensure that we're all getting the same answers. Now, I know part of you are like, whoa, we get random numbers from the calculator here. They should be random. We should never get the same answers. And you're correct, 100%. 100p. But right now, I want to make sure that we're all getting the same numbers. So what we can do is basically we can synchronize our calculators, if that makes sense. So we're going to synchronize them. What you do is you just put a number in and you store it into a random function. And what it does is it puts you in a certain place and we're all going to be in that same exact place. And that's just going to guarantee we get the same answers. And I have to do this a little bit so that when you pick your numbers and you check your answers, you can know that you're doing it correctly the same way that I would do it. In practice and in real life, we would not do this. We would let our calculators just shoot out random numbers and not know what's coming out next. So with that being said, I'm going to teach you we're going to seed, it's called seeding our calculators. What we need to do, and I'm just going to use the numbers 1, 2, 3, 4. And you hit the store button, which is down here to the left of the 1. And we're going to go into the math. We're going to go back to the probability where we were before, and we're just going to hit rand, which is choice 1. And when you hit enter, it just comes with 1, 2, 3, 4, pops that out. But now we are all in the same place in the random, table of digits. Our calculators are basically all synchronized, so we should get the same answers. All right, so I'm going to give you a little hint when we do these problems. Seed your calculator to this so we can all get the same answers and just to make sure we're doing it correctly. But as I said, I want to emphasize, in practice, we would not do this. So that being said, students are numbered 1 through 720 at Kaiserslautern High School. Select 5 students to participate in a game for a pep rally. So we have a calculator. I just seeded it to 1, 2, 3, 4. So now I'm just going to go to math. We go over to our random integer, which is choice 5. And we're going from 1. We're going to number the students from 1 to 720. And if you want, this time what I'm going to do is I'm just going to change that to 5. Or you could have left it 1. Doesn't matter. But when you hit enter, you get that command and you see the 5 students right there. Okay, so the 5 students are students number 16, 131, 68, 21, and 271. All right, so we're just going to write those numbers down, and that will, it'll show your teacher that you know how to do that as well. You get the same numbers there. We all should get the same numbers here, right? What happens if one of the numbers repeats? We just talked about that. You just select one more number. All right, example 2. Pause the video, and you do example 2 all by yourself. Don't forget to see the calculator. This time we're just going to use 20. It's just a number I'm picking, so we all get the same answer. Go. Okay, we're back. Hopefully you got students number 478, 62, and 266, whoever those students would be. So remember, because these numbers come out randomly, you might have repetitions. And if that happens, just ignore it and then select a new number. That's kind of why I like to select them in ones, because then if I get a repetition, I can just hit the button again, but I think you guys can figure it out. All right, so now we're going to talk about the different types of sampling designs. It's another way of saying, how can we go out and sample people? We just did, which most stats people think is the best method. We did what's called a simple random sample, or an SRS. We say SRS for short. Okay, that was fancy. But a simple random sample essentially is where you number everybody off and you select the numbers randomly until your sample is complete. So if we want 50 people, we just select 50 people, using a random, the calculator is fine. And so that, statistically, that's what is the most popular, probably voted prom king. It's, everybody uses it, so that's the best one. But it's not always possible because you can't always list everybody and give them all a number. Like if, you're a television station and you want to learn about something on your television program, you can't just number everybody that lives in your city and then go find them. So sometimes we use different approaches. Another approach would be a systematic random sample. And we do this like the first individual is chosen at random and then you use a system or rule. So maybe we select a customer at a store randomly and then, what did you think of lunch today? And then we ask every 50th customer. We watch them go through, what did you think of lunch today? The 50th customer. And we're counting. So because there's a system or a rule, then that's called a systematic random sample. You could do this at your school. Get a list of students and go down and just pick every 20th kid if you want to learn about your school. That would be a systematic random sample. Another type, we have a stratified random sample. Okay, now this is often confused with a cluster sample, which is down here. But let's talk about stratified random sample first. So what a stratified random sample is, it's when you want to ensure that every single part of a subgroup is selected. So what could that mean? I'm going to go back to my school lunch analogy. It's very popular for me, not the lunch, the analogy. But suppose you wanted to learn about your school lunch and you wanted to make sure that 4 different groups of people, you wanted to make sure that freshmen, sophomores, juniors, and seniors all are in your sample. If I did a simple random sample, then it's possible, although not likely, but it's possible that my entire sample could all be freshmen. Or it's possible that they're all seniors. Or it's possible they're all girls or boys or whatever. So sometimes beforehand, you say, okay, I want to make sure that I get freshmen, sophomores, juniors, and seniors. So what you do is you divide your students into those groups, and then you select randomly within those groups. So if I wanted a sample of 40 students, I could go to the freshmen and select 10, and then go to the sophomores and select 10 different ones. And I would make those selections randomly, and then that would make up your entire sample. If you do that through the 4 grade levels, you would have 40 students there. So that is a stratified random sample. You put them into groups, and the groups are based on something that's in common. So whether they're freshmen, they're all sophomores, or maybe you want to get so many male, so many female, so you select so many male, and then you select so many female. That would be stratified, just to ensure that each one of your subgroups there gets selected. This is often confused with what we call a cluster sample. A cluster sample is where we select essentially a subgroup, and then we just survey everybody in that subgroup. So at Kaiserslautern, we have neighborhoods. They're like hallways that are, except they're not halls, they're neighborhoods. If I wanted to select a sample and I wanted to know what students thought about a particular subject, I could select 2 neighborhoods randomly, and then every kid in there, I'm just going to get their opinion. Now, the difference between the two, if the groups have something in common, then it's stratified. If it's more, I don't want to say out of convenience, but if you go out there and you select 2 and you say, I've got everybody in here, that is a cluster sample. You're grabbing a cluster, from, different areas. So another way to think about it, if you randomly select several teachers and then a class, and you choose all the students in that class, That would be a cluster. Okay, I want to know about something in the school. All right, pick a teacher, pick a class. Now just give me everybody in that class. It's a cluster. It's more convenient than stratified because you could just go out and get it quickly. Okay, so that's a different way to do it. 2 more ways. Now I'll give you some caution. These are not as good. They contain more bias usually, but they're popular because they're easy. Okay, the first one is voluntary response sample. People choose themselves to be in the sample. Would you like to participate in this? And most frequently, and we do this a lot at our school, and you probably do it at yours, we post a poll on a social media and we ask for input. Okay, what did you think about, whatever, the school lunch? You can use school lunch for everything basically, but what did you like about the school lunch? Please tell me your input. The problem is only people with strong opinions tend to reply. It's not the person who's going to reply that says, I don't know, it's all right. Those people don't reply. It's usually the strong opinions, most frequently negative. They have something to complain about. So they are overrepresented in your sample. You get a sample that's basically negative with a few really good positive, and then you think, oh, this is what people think. When in fact, that might only be 5 or 10% of the population. Most people could be okay with whatever you're doing. So that is a voluntary response sample. They voluntarily choose to respond. And another one could be a convenience sample. Individuals are easiest to reach are chosen for the sample. So the example I used with the cafeteria, and you just go out there and you just sample people, okay, well, there's some bias potential in there. Just because, they're easy to reach doesn't mean it doesn't mean it reflects the entire population. I could just ask or a teacher could just ask their entire class, what do you think about, whatever topic? The problem is different classes are different. You have AP calculus classes. You have PE classes. You have, freshman classes. See, they're not representative of the entire population. So even though it's convenient, it's not necessarily a good sample that represents the population well. Okay? These are biased samples because they may favor certain outcomes. If you ask the seniors, it's going to tell you what the seniors want, not necessarily what everybody wants. Okay? Now, we're going to talk about types of bias. So bias, as we said before, is when your sample doesn't match your population. So what could happen? We could have what's called undercoverage. Some groups are left out. If you do a sample at school and then kids are on a field trip and they're not involved, that's called undercoverage because they were left out of your sample. Or you could have non-response. Please tell me what you think about this. Oh, I ain't telling you nothing about that. Okay, I refuse to cooperate. That is non-response. Response bias, the way I ask you the question. I could come up to you and be like, you don't think, school lunch is good, do you? Okay, the way that I'm acting towards you, it's going to solicit a type of behavior in the response. Okay, or it just might be the students want to lie. Like I come up and say, hey, have, risky or socially discouraged behavior. Like, do you like Mr. Bean's videos? Okay, that's socially discouraged probably, right? You're not going to say yes to that. For goodness sake, be an outcast. Lastly, but most important, probably the wording of questions. If you have confusing or leading questions, that could influence the responses. So here's 4 questions, basically the same question, but asked different ways. Do you like the new school at Kaiserslautern? We have a brand new school here. It's 21st century. That's one way to ask the question. Another way, do you like the new $75 million state-of-the-art 21st century school at K-Town that has integrated the latest educational and technological advances into teaching and learning to support our military community? I gotta be honest, that question is so long, I fell asleep halfway through and I was reading it. Okay, plus it has, all these buzzwords in here that make me want to say yes. I just want to say yes to that. How about the third question? Do you think the new school at KHS is worth $75 million? The $75 million burden it caused taxpayers, even though the school still teaches the exact same classes. Okay, this is going to solicit some negative responses. I don't know if it's worth it. That's a big burden. That's $75 million. Instead of thinking of it like, we spent $75 million on the latest technological advancements, we think of it as, you cost us $75 million, so you're going to have a different response. And do you like HS where the famous Corey Sullivan teaches? Or despite Despite the famous chorus. Anyways, my point is the wording of the questions can solicit it can introduce bias where different responses come back. So now it's your turn to practice a little. Read this, do example 3 all by yourself. Ready, set, go. Okay, so what did you get for this? For the following situation, tell what the population and sample are. Also tell the sampling design and indicate whether there are any sources of bias. All right, the question is, we put it on flipmath.com. Students could respond to it. Do you think Flip Mastery teaching helps students learn better, like our data suggests? Like how we slid that in there, right? All right, so what's the population that we're, trying to learn about? So I would argue that the population is basically all students. I want to learn about students. All right, now what is the sample that we actually are going to get? Well, if we pose this question on the website and we're getting responses, the sample would be basically any kid that responds. It's not necessarily all the students, but the students who respond. Now, when we're talking about our sampling design, like how did we collect this data? Well, it's pretty convenient. We just threw it up on the website and then people more or less they send in their data. So this would be a convenience sample. And lastly, what type of bias could there be? And I would argue that there's undercoverage because not all students are probably on our website and answering the question. Not all students actually answered it. So there's one type of bias, undercoverage. Another one could be wording bias because look, I ended it with like our data suggests. So we have to be right, correct? Okay, it has to be better. So there's some wording bias in this question here. And there's probably other biases as well. Okay, these are answers that are, there are probably some right answers, but you could argue different answers could be correct as well. So that basically concludes, the lesson for today. You have to make sure for this lesson that you're seating your calculator when you select different people for the samples and, go through and there's not a lot of math here. It's more words. Congratulations, lots of words. I'm going to end my words right there. This is Mr. Kelly in Kaiserslautern. And remember, it's nice to be important. More important to be nice.